There you see the Ikawa up close and personal. And what we're going to talk about in broad strokes here is we'll introduce you to the Ikawa. Assume you're more or less familiar with it, and we'll go over that. We will talk about what a sample roast is. So we're talking about sample roasting on the Ikawa. What is a sample roast? What are we trying to achieve? How to create an acceptable sample roasting profile or profiles on the Ikawa. And that's an interesting question because generally speaking, sort of historically, using the language of profile, you're talking about a production roast, and sample roasting is not profiling usually. But because of the unique way in which the Ikawa works, you have to generate a profile because it runs profiles via the software. So how do you create a profile that works for sample roasters? And then our conclusions. So first off, introducing the Ikawa. Traditional sample roasters, you see Gavin there who works with us at Atlas sample roasting on a vintage Probot 5-barrel sample roaster. Traditionally, these have multiple small barrels. They're open to the air. They're not a closed environment like a production roaster usually is. Traditionally, no measurements. Certainly in the old vintage one, there's no measurements, no air temperature, no bean temperature, no nothing. So the newer ones have air temperature, but that only has very rough use. Small max capacity for roasts, and these are heavy. And the reason to point that out is because they're not at all portable, especially these old ones are all cast metal parts, so they weigh about as much as a small electric car. They're very, very heavy. And in addition, often they're gas. There are electric sample roasters, traditional sample roasters, but often these are gas, which means they're plumbed in, which means, again, they are not portable. Here's another photo from our office. We have 2 of these, and you can get a sense of the scale. These are very heavy. They're ducted in, they're plumbed in. They're not mobile, which leads me to kind of one reason why this class is a part of our first series in the stay-at-home online education. I'm at home. I'm giving this presentation from home. When we all moved home from the office, I couldn't take these with me because they're stuck at the office. They're heavy, they're plumbed in, but I could bring the Ikawa home with me. And if any of the rest of you are in that position of working from home when you're not used to working from home, the Ikawa is a solution for that because it is quite portable. I don't know if Susan's here yet, but James, are you familiar much with the Ikawa? How much do you use one? Do you have access to one?
Yeah, we have one here at our office. I have worked with other importers in the past when I was working for a roaster who use them for like their traveling road shows to go and do like public cuppings back when that was a thing. And but yeah, that's about as familiar as I am with them. What you've just gone over, anything kind of beyond that is still a mystery to me. But I'm looking at one right now.
Great. So in contrast to a traditional sample roaster, these are highly portable. They're electric, so the heating element is electric, and they use air, heated air to pass over the coffee rather than gas, which adds to their portability. You don't have to have a gas source. You can travel anywhere where there's electricity and plug it in and run the roaster. It's app-based, which is very convenient for many of us who have smartphones. It's very measurement-based. So remember, I said about traditional sample roasters, there's often no thermocouples unless you've modified your roaster. It's really based on observation and kind of the skill of the operator, which obviously could vary in experience and skill. but the Ikawas are very measurement based. They're exceptionally easy and convenient to run once you've created the profile. So the work is in creating the profile, which we're going to talk about today. And after that, you're kind of pushing a button and it's magically doing its thing. They're highly repeatable, which even great human sample roasters who operate traditional sample roasters can't be as repeatable as a machine. They do very small batches, 50 grams, which can be a challenge if you're trying to do traditional SCA cupping, because one batch isn't enough for that. But because they're highly repeatable, you can just do 2 batches of coffee if you need those 5 cups SCA standard cupping. Right now, cupping from home here, my dishwasher can't handle 5 cups of every sample. So I'm quite happy to do 2 or 3 cups of coffees that I'm cupping here at home. And 1 batch at a time through the drum, so or through the roasting chamber. Because I didn't know how familiar people would be with the Ikawa, I've got some slides here just to kind of run us quickly through the nuts and bolts of how to actually operate one. I was going to do a video, but and I do have one video in this class that you will experience, but I was worried about buffering and such, and I thought it might be easier to do this with photos. So it's kind of a step-by-step photo instruction of using the Ikawa, and you'll see how intuitive and user-friendly and simple it is. In terms of operating the machine, you can see the outside. It's elegant. There's not a bunch of sort of bells and whistles on the surface. A lot of what is done in the app. And that makes it look sleek and attractive, I think. And so when you're ready to start roasting, you push the button, as you see here, and it begins the heat up cycle for the roaster. And then the light will turn red and start beeping on it. It doesn't beep audibly, but going on and off to let you know it's heated and it's ready to go. The kind of hopper then is right here on the top. And you can see that has kind of a hole in the side of it that when you turn it around, it opens to the roasting chamber and drops the coffee in, which you'll see pictured here. So when it's ready, when the roaster itself tells me that it's preheated, I can drop my coffee in that hopper and then turn it 180 degrees, and then the coffee starts to fall down to the roasting chamber. And then when it all falls into the roasting chamber, I can continue to swivel it around, and the roaster won't start roasting until it senses that hopper is closed again. So once I swivel it the other 180 degrees back, it starts to roast. The roasting happens, it's amazing, and it's magical. And then after the roast is done, you have chaff that's collected in this chamber here. And you empty the chaff wherever you want to put chaff, in a trash bin. And then there's a second button on the outside. You press this, and the motor revs up, and it uses air to move all the coffee down into this glass chamber here. And your roast is done. You can take it out of the chamber. And that's it. I mean, it's really 2 buttons that you're pushing, and then you are letting it do its work. Now, behind that is the app. And here are 3 screenshots from my phone showing the app. And this is newly updated. They made some nice improvements to this that make it even more convenient and user-friendly. On the left, this is the profile library. So you can save all kinds of profiles for different coffees, different purposes, and select the one that you want to run and send it to the roaster. And once that's sent to the roaster, it gives a little indication, a little pop-up saying that this profile is on the roaster. That roaster will run that profile until you change it to a different profile. And then in the middle there, you see the screen that shows a visual representation of each profile. And sort of the red-orange line is your profile plan. And you can put fewer or more data points on there where you want it to change direction. It's very easy to do that. And you can adjust and edit the profiles from the screen by using touch and kind of drag those lines out. If you want to make it a 9-minute roast or a 10-minute roast or make it shorter, you can just do that by touching the screen and adjusting those. The white line below is the fan speed of the airflow, which is another thing. When you're planning a profile, you're adjusting the temperature hit points of the bean, but you're also adjusting the airflow levels, and we'll talk about that further on. But one thing that I like too about their update is when you're dragging the profile around with your fingers, sometimes it's hard, especially on a little iPhone, to be super accurate. Maybe I want it to be 410 at exactly 6.5 minutes, but with my finger, I'm getting it at like 409 at 6 minutes and 27 seconds. But you can actually go into the screen on the right and type in exactly what you want for each of the points in terms of bean temperature up top and the fan points down below. So it's really very convenient to program a profile. And once you program these profiles, the machine does what you tell it to do. So that's the trick. That's what we're going to be talking about today. How do you come up with a good profile? Because the machine doesn't know what a good profile is and what a bad profile is. It will do amazingly well what you tell it to do. But if you tell it to do something that isn't going to taste good, it's going to do something that isn't going to taste good. You're the taster, and it is the one that fulfills what you ask. So this is an example, too, of what the screen looks like during a roast. It actually tracks an individual roast in real time. And the orangish line follows the actual bean temperature over the profile that you see in the background. The yellow line is the air temperature. Now, air is what it's using to heat the bean. So it does whatever it needs to do with the air in order to achieve the profile of the bean temperature that you have set. But it shows you both there. Shows them both there. You can actually put markers in there, and you can see I've done that there, those dotted lines. CC for color change, and first crack is indicated there as well. So those are optional, but if you want to keep track of those things, you can. And then one thing about an Ikawa is that it cools the coffee down in the roasting chamber. So you can also see the cooling process there. It hits the end of the roast at 8 minutes in this profile, and then it starts to go into cooling phase, which in this case is an additional 2 minutes. And you can see the dramatic and quick sort of falling off the temperature cliff there in the profile. So the Ikawa roaster has many, many applications, and Jeff from Ikawa was, I've talked to a lot of people who have used it in a lot of different ways, but he supplied a lot of ways that they have heard that people have been using these roasters. They're used for profile roasting, finding profiles that you might apply to a bigger roasting machine. They're used for QC and monitoring of coffee inventory throughout the supply chain, from people who are exporters at origin to importers to roasters, and so on. Used in cafes, roasting to order. Used in roaster training because, in training a roaster, you can go through a lot of green coffee. And if you can teach them a lot with just 50-gram batches, what a win. Cupping training, they can supply coffee for that. Coffee competitions, this is a use that I see quite often with the Ikawa. Coffee sales, a lot of people who are doing sales in coffee will cart these around with them or use them in their home offices and so on. And then there's sample roasting, of course, which is what we're talking about today. And I didn't realize it until talking with Jeff from Ikawa. But sample roasting was actually one of the key, if not the key, purpose in their original design, because Andrew, who originally designed the Ikawa, his father worked as a consulting agronomist in Africa and realized that it was very difficult for a lot of people on the producing side to adequately be able to roast their coffee, to sample roast and to taste their coffee. And so that was actually one of the founding reasons for the Ikawa to exist. So that's an introduction to the Ikawa. And then I promised you we would talk about what a sample roast is. What are we trying to achieve with this wonderful tool? So a sample roast is to make purchasing decisions. And that's kind of its primary distinction, different from a production roast where you're trying to sell coffee to please your customers. Sample roasts are all about making a purchasing decision. So you want a clear, unbiased look at the potential, the character, and the value and the quality of a particular coffee. So in a sense, although you can't have coffee without roasting it, we're trying to make a roast that is neutral, if it will, a roast that is unbiased, that is clear, and just allows you to say, this coffee works for my purposes, or it does not work for my purposes. I want to buy it, yes, or I want to pass on it, no. It is not profiling. It is simply trying to make roast not a factor and be in the background and allow for a clear assessment and decision making. There are standards around sample roasting. So these are set by the SCA, and standards as they exist today are that the coffee should be roasted 8 to 24 hours prior to cupping. They should be roasted to a medium light color, which is defined as a 63 on the Agtron plus or minus 1. So there's a color as defined by Agtron or other color reading devices. And they should be roasted in 8 to 12 minutes. Now, arguably, so this doesn't give you much to go on. This is the standard, but all the standard really gives you is when you should cup the coffee, which really isn't about roasting, what color it should end up being, and a time, 8 to 12 minutes. But we all know if we roast coffee, there's a lot more to roasting coffee than just, oh, it's been 8 minutes, it's done. And the Ikawa makes that very visible because you see a real profile happening in real time. So arguably these standards they clearly were made not with the Ikawa in mind. The Ikawa didn't exist when these standards were put in place. And the Ikawa really kind of blurs some lines between what people expected out of a traditional sample roaster and then what roasters talk about in terms of profile and whatnot. Also, as you'll see from our presentation, I'm not sure that the 8 to 12 minute rule is necessarily best for Ikawa. So what are the standards? Why are they here? What are they trying to achieve? The standards the SCA has set for sample roasting. It is a repeatable, consistent roast level where roast is not a variable. It should be the lot that you're deciding to buy or not buy that is the variable, not the way that you cup, not the way that you sample roast. And we are looking for specific, recognizable sample roast sensory characteristics. Okay, and so in reality, when it comes down to it, 63 Agtron or not, we know a sample roast. Trained cuppers know a sample roast by taste. We know when it hits the mark and when it doesn't hit the mark. So at some level, because coffee is not something that we do to look at, it's something to taste. When it comes down to it, a true and proper sample roast is a recognizable taste profile, not a color. And Q graders learn to recognize this as a part of the Q program. They're tested on being able to taste and identify whether something is too dark for a sample roast, too light for a sample roast, or correct, or even roasted too long of a time. And so if you are a Q grader, you have shown yourself successful to recognize this by taste and not by color. What should a sample roast taste like then? Well, here are a few ways to think about that. There are some compounds potentially in coffee, trigonelline, and also chlorogenic acids, which I don't mention here in the sort of title, that really lend to green, vegetal, and raw grain kind of generally unpleasant flavors in coffee. And these are quickly roasted out around first crack. Okay. And shortly after first crack, these really substantially decrease. So the trigonelline in coffee is represented, and this isn't based on real numbers and real science. This is an illustration. Sometimes when you use charts, it's based on real numbers. This isn't. But if you can imagine roasting through time and you hit first crack, and the trigonelline in the sort of orange color dramatically goes downhill once you've hit first crack. And then another set of compounds are pyrolytic compounds. These are essentially burning compounds, sometimes called dry distillation. And so at some point, as you roast along through time, the roast starts to pick up this other series of compounds. If you drop a coffee at point A, you're going to avoid all that dark line, the pyrolytic compounds, because those haven't been created yet in the roaster. However, you're going to have very high trigonelline and chlorogenic acid, which is going to make the coffee bitter and raw and vegetal and grain-like. If you finish the batch at point B here, you're in this lovely window where you don't have a lot of trigonelline, but you also don't have roastiness or pyrolytic compounds. And of course, if you roast all the way to point C, you have done away with the green, raw, vegetal trigonelline, but you have also picked up pyrolytic compounds which mask the flavor. So really what we're shooting for is point B, where you have diminished the green and raw vegetal flavors, but you haven't generated yet the pyrolytic compounds. If you've taken the Q course or just been familiar with the Le Nez de Café aroma vials and how they're divided into 4 aroma sets, you may know that in coffee we talk about enzymatic aromas represented by things of the plants. When you think enzymatic, think things that come from a plant: green, vegetal flavors, floral flavors, fruit flavors. These are enzymatic. There's also sugar browning flavors in the top right-hand side. Lower left-hand side, dry distillation, which is the same as these pyrolytic flavors. And then there are aromatic taints, which come from storage of the coffee. Another way to look at what a sample roast is intended to be from a flavor perspective is that 2 of those 4 aroma groups are things that are very valuable when we're selling coffee. And when we're purchasing coffee, which is what sample roasting is all about, we're trying to purchase something that presumably we can sell to our customers. So we want to know what these valuable qualities in the coffee are like. How good are they? How intense are they? And so on. We want to know what the enzymatic properties and what the sugar browning properties of our coffee are. Unfortunately, these 2 different groups of aromas develop at different times in the roaster. So first in the roasting process, the enzymatic properties are brought to their peak like a bell curve. And again, this isn't based on real numbers, it's just an illustration. And then they start dying off. And then the sugar browning characteristics start to reach the top of their bell curve, and then they start dying off. And after that, the dry distillation picks up. And I haven't pictured that here. So if we finish our batch here at point A, we have the absolute peak of enzymatic, but you can see the sugar browning, that orange-brown line, is not very high yet. So we're getting a lot of the enzymatic character in our sensory evaluation, but we don't know how good the sugar browning properties of this coffee are. If we drop the coffee at point B, we've lost a little bit of the height of the enzymatic character. We have not yet gained the full sugar browning character, but both of them are reasonably high. So we're getting the best of both worlds. And then if we drop the coffee, finish the batch at point C, we're getting mostly sugar browning. And you can see the green line is actually quite low. We've lost a lot of the enzymatic. So point B is the goal. We want a sample roast where we can evaluate both the valued enzymatic properties and also the valued sugar browning properties, even though there's a little bit of a give and take. Now, how to create an acceptable sample roasting profile or profiles on the Ikawa, which is maybe what you're here for. And a big starting question for me, and I did not know the answer to this when I started all of this work that I'm going to detail here. Is there a single universal sample roasting profile that is possible? The Ikawa is capable of you saving in that library so many different profiles, and they can all it's really endless and infinite in the amount of profiles that you can create and what you can do. And one of the challenges with sample roasting at any scale for an importer or for a roaster is that you're likely to receive a lot of coffees that are different. They're from different places in the world. They have different densities, different cultivars, different moisture contents, and so on. And that's one of the inherent challenges to sample roasting, no matter what machine you're using, is how do you create a consistent outcome when your inputs are all different? And in some cases, you might only get 100 grams or 200 grams or something like that from the farmer or whatever. So you don't have much to waste. You can't try it over and over again and keep getting it wrong. You have to get it right. Is a universal sample roast profile possible that will apply across a vast, different groups of coffees that have different moisture contents, come from different places, different processes, and all of that? And if not, what are the fewest number of profiles that can adequately cover the vast majority of coffee, so that we don't have to think too much and switch a profile? You wouldn't want to get into a sample roasting situation where every individual coffee that you sample roast, you have to have its own unique profile for, right? That would be a lot of work. So these are some of the big questions that I had going into this. And actually, initially, for the first really, couple of years that I was working with the Ikawa, I did have several different profiles, 3 or 4 different profiles that I was using for sample roasting, different types of coffee on this. So I kind of came into this thinking there is not going to be a single universal sample roasting profile. I'm going to have 3 or 4. Where to begin for any of us as we address this question of creating a profile for sample roasting? It's going to be limiting variables. So the Ikawa is amazing in that the variables are infinite, but it can also be bewildering and challenging to know where to start then. What should I do to create a sample roast profile when really I could do anything and the roaster is going to listen to me and accomplish that thing? So to some extent, limiting variables is always a bit of an arbitrary process, but I think we can go through this. And what I have done here is, I think with intelligence and certainly intention, gone through the process trying to limit variables and to look at each one as I assess what worked for a sample roast profile. So my starting assumptions when I did this work were based on maybe 2 years of previous work with the Ikawa. I was looking for an 8-minute roast, mostly because I wanted to fit it into the SCA parameters, and I knew that 9, 10, 11, 12 minutes, which are also acceptable in the SCA parameters, were probably too long to begin with. So 8 minutes is the fastest I could roast and still meet the standards technically. And then I was looking for an end temp that was likely going to be between 410 and 420, just based on my previous use of this machine. Another assumption I had was to use Dietrich roaster style airflow, and that's just something a way I've become accustomed to thinking as a roaster. And if you're not familiar with that, the idea is to use less airflow when the coffee is green before it yellows, because that helps deliver the heat into the core more efficiently, and then to use more airflow after the coffee turns yellow. So you might not agree with that, you might do something different, but that's a foundational assumption to how I dealt with the airflow working with the Ikawa. And then I had another assumption that for flavor, the more airflow, the better after that color change point. So less airflow before the color change and as much as possible after the color change. And then a no frills profile was what I was going for. If you're competition roasting, your profile, you're using the Ikawa for competitions or profile, do whatever you want. But for sample roasting, when so many sample roasts don't even use thermocouples, I thought, let's just get from point A to point B. No frills profile, as simple as possible. So the shape, here are two different profiles. First, I conceived of, I want my end time to be 8 minutes, and I'm going to start at 200 degrees, and I'm going to end at 420, and so it's going to look like a straight line. Okay, that would be the simplest shape possible within those parameters. However, what I found is that the second shape there, moving from left to right, so the right profile, was a little bit better shape. That's sort of not just straight uphill, but a little bend for some development time at the end. Otherwise, using different types of coffee, it would hit first crack at very different times because some coffees need a little more energy to hit first crack. And so having this little like a ramp up and then a little bit of a dwell time or development time gave time for that heat to kind of really settle in and to create first crack in a relatively even way across different coffees. So this is the shape that I went with in all of my experiments. So my first experiment was then about time. And my foundational assumption was I want to try, I hope 8 minutes is right. 8 minutes is what the SCA recommends, but this is an entirely different kind of device, so maybe it isn't. So taking this basic shape, I put the same shape to the same finish temperature at 4 minutes, 5 minutes, 6 minutes, 7 minutes, and 8 minutes, and cupped them blind. And that little bend at the top for dwell time, I kept at the same percentage. So that's sort of the development time, which was at 18.75% of the total roast time. So that the percentage of that never changed. And because part of the challenge of sample roasting is the fact that we're dealing with a lot of different coffees, I wanted to make sure that this applied well to the flavor of many different types of coffees. So most of this testing I did on these 4 coffees here: Brazil, Samambaia, Obata Natural, which is the least dense coffee in the set, a Myanmar Natural, which is the second least dense coffee in the set, an Ethiopia washed Guji.
Hey, Drew.
Yes.
There's a question from Susan. She wants to know if it is standard to have 200 degrees as the starting temp.
Yes, I mean, that mimics what's kind of normal for a production roaster, and it's also standard on the Ikawa.
Cool.
And then Ethiopia, which comes next in density, so it's getting more dense. This is a washed Ethiopia. And then in Nicaragua, La Esperanza, which is also washed and had the highest density of any of these 4 coffees. So I roasted these, and I cupped them at home. This is my home cupping setup currently. They're blinded and coded with numbers so that you can see I am doing this fairly. And here are my results. from this time cupping. And what I did when I cupped each set, and I actually included a Sumatra in this as well. So there are 5 coffees in this initial test. Each one was roasted in 4 minutes, 5 minutes, 6 minutes, 7 minutes, and 8 minutes. And I wrote down flavor notes for each of them, and I'm cupping them blind. I knew which ones were Sumatra, which ones were Ethiopia, which ones were Myanmar, but they were randomized other than that. And I also tried to guess by flavor, which was the 4 minute, 5 minute, 6 minute, 7 minute, and 8 minute. So where you see 4, 5, 6, 7, and 8 in gray, those are the answers essentially. And where you see them kind of color coded, those are my guesses. And so in every case, I was able to guess the 4 minute, 5 minute, and 6 minute roast. In a few cases, I mixed up the 7 minute and 8 minute roast, which is good. It means those are largely indistinguishable or both successful roasts in most cases. But it was very clear that these fast roasts led to some of that sort of trigonylene green raw flavors across the board, 4 or 5 minutes. And that's why I've colored them red, because these are unacceptable sample roasts. According to that profile shape at 4 and 5 minutes, it was not able to produce a clear, clean roast for sample evaluation. At the 6 minute level, I actually coded these yellow because they're sort of on the verge in all of them. If you read those flavor descriptions, if I was in a pinch, I could have made a buying decision, but they all had some drawbacks, often in the finish. The finish was a little abrupt or drying or grain-like or something like that, but I could taste the true character of the coffee. Moving into the 7 minute roast, if you look across the board from left to right at 7 minutes, this is where the flavors really come into they're very vibrant. For the Sumatra, earth, chocolate, raisin. For the Ethiopia, berry, melon, sweet spice, and so on. And you can see all across the board, they get green marks. When we get to 8 minutes, this is interesting, because remember, 8 minutes is the SCA standard. That worked well for some of our coffees, but actually the Ethiopia and the Nicaragua did not do well at 8 minutes time. They started to pick up, in both cases, some dry distillation flavors by 8 minutes. Now, both of these two coffees are the driest. The Ethiopia is 9.6 humidity, and the Nicaragua is 10.2 humidity, which may be a factor. I'm not sure exactly what caused this, but this is what I found, and this was blind. I didn't know which was which until I unveiled it. And so what this shows me, actually, if you really are a stickler for standards, you might persist in 8 minutes. But what I found is that the 7 minute roast actually works for all of these very different coffees and gives the best flavor. So onward from that, endpoint temperature. So all of us who are roasters know that the final temperature of a roast actually has quite a fair impact on what it tastes like. So I took the 7 minute roast, which proved itself time-wise to be better, and that profile for the 7 minute roast, and had a different end point at 412 degrees, 416, 420, and 424, and did the same kind of test with the same 4 coffees that we did last time to see what temperatures are acceptable for sample roast that are not either too raw and trigonylene green or roasty. And here are the results of that testing. So you can see each of the 4 coffees, Ethiopia, Myanmar, Brazil, and Nicaragua, moving from left to right. And then what I did in this case is I have flavor notes for each one, and this was again blind. And I wrote down my flavor notes, and I also just said yes or no, this works as a sample roast or it doesn't, before I turned it over and unveiled what they all were for myself. So at 412, you see that the Ethiopia and the Myanmar and the Brazil have unpleasant flavors. The Ethiopia had this kind of green seaweed flavor. The Myanmar was kind of raw and very nutty and papery. The Brazil was sour, vegetable, grain-like. However, the Nick actually worked at 412. It had a bit of an abrupt finish, but it was sweet, it was lively, it was a decently clear sample roast. And then moving to 416, 416 actually worked for Ethiopia. It was actually my favorite among these. I didn't indicate my favorite in this chart, but it was floral, spice, sweet, marmalade, botanicals, great balance. 416 and temperature worked for Ethiopia. However, it didn't work for the Myanmar. The Myanmar had really raw celery, grippy, and cereal notes, in addition to some fruit. The Brazil, this lighter roast, did work for it. It was lively, nutty, and toffee, slightly drying, but it would work for decision-making purposes. And then the Nicaragua, of course, worked. When you get to 420, and you can see I've kind of darkened the line around this whole row, all of them work across the board. At 420, works good for every coffee, regardless of natural or washed or low moisture, high moisture, and so on. So it wasn't always my favorite roast, but it worked for everybody. The Ethiopia was better at 416. And then you could try 418. I didn't do that in this test, but I will mention there are numbers between 416 and 420. And then 424, so a little bit darker, didn't work for the Ethiopia. It started to pick up some roastiness, and it didn't work for the Nicaragua. It again it had clear dry distillation for the Nicaragua. But actually it did work. The darker roast worked for the Myanmar and worked for the Brazil. So different coffees respond differently to the same profile. But what I'm looking for here is a universal profile, so I don't have to change all the time for every coffee. And 420 degrees end temperature at a 7-minute roast is where we're at. Now I wanted to take a moment to talk about airflow. Airflow is another variable that you can control and that you need to control on the Ikawa. And on the Ikawa, you have the ability to set it anywhere between 60% and 100%. That's your window of variation of the fan speed. Now, my assumptions are that less airflow is better leading up to the yellowing of the coffee, and more airflow is better later on the roast after yellowing takes place. Now, here is where I have a video. It's not terribly interesting. There's no techno music playing in the background or anything. You'll just hear the fan, and if you listen closely, you'll hear first crack happening. But I want you to watch this video, and it showcases two things that you need to think about in terms of airflow when you're using the Ikawa roaster. So here you see if the airflow is set too low for the density of the coffee they're using, this coffee is roasting right now, but it's not moving because the airflow is too low. And this is a problem. This is going to be a roast problem for you, but it also could potentially start a fire. So you want to make sure that the airflow is always moving enough that the coffee is stirring and moving around. On the other hand, watch this coffee later on. I think we already heard a little bit of first crack. This is at the end of the roast. And if the airflow is too high for the density of the coffee, it starts carrying off some of the beans. And you can start to see beans being pulled off out of the roasting chamber by the air. That it's supposed to suck chaff, but see, and I slow it down here so you can see these beans are actually being sucked out with the airflow and with chaff because the airflow setting is too high for this particular coffee. And so we move down here to the chaff collector, and it's collecting not only chaff, but it's collecting your beans. And when that happens, that means that this coffee that's down there at the bottom is not reaching the end of the roast cycle. So it's not adequately roasting. Not all the coffee is following the roast profile, and some of it is down here. So you want to avoid those two things. One, airflow being too low, because then the coffee is not going to be stirring and moving. Two, airflow too high, because then it sucks the coffee out of the chamber. And it's different for different coffees based on density. So density matters here, because the lighter a coffee is, density, the more likely that it is to be sucked out. The heavier a coffee is, the more likely it is to stay in the roasting chamber. However, the heavier a coffee is, the harder it's going to be for it to stir in the beginning if you don't have high enough of an airflow. When does density really matter in the roast on an Ikawa? Well, from here on out, about first crack. So actually, my initial idea was, as soon as you have the color change in the coffee, it's best to have as much airflow as you can possibly have. But as coffee roasts and hits first crack, it always becomes less dense. It's significantly losing density first crack and afterward. And when you have it lose density at the first crack moment, it's easy for the airflow to suck it out. So you can actually, if you look down at the white line, which represents airflow, you can manipulate the airflow to be higher during much of the browning phase. And right when it hits first crack at that orange-brown line, you can drop it lower so that just as the coffee is losing density, the airflow is becoming lower so that it doesn't suck all the coffee out of or some of the coffee out of the roasting drum. So the last big tasting experiment that I did was a comparison of airflow and its effects, both practical effects and taste effects on the coffee. We are now doing, in this one, I chose to do an 8-minute roast rather than a 7-minute roast because I wanted to see how, so the longer that you roast, that impacts density as well. So I wanted to see how it, at the longer side, it worked with the density. But we're using 420 degrees here. And the only change was the airflow speed. And if you can look here at these different profiles, you'll see the airflow set points and what percentage the airflow was at different times in the roast. It's all the same at the beginning of the roast and up until 6 minutes and 30 seconds. It's all following the same thing. But after 6 minutes and 30 seconds, which is our sort of rough first crack time period, I moved it down to different percentages of airflow. And we tried all these coffees during first crack development time period at 70% airflow, 75% airflow, 80, 85, and 90. So that's what this test is. And here are the kind of raw results in sort of numerical form. You can see they're organized according to density. And what I've captured here is, if you look all the way on the right, the last few columns on the right, is how much weight remained in the roasting chamber to the end of the roast, and how much weight was sucked off with the chaff and the airflow, depending on how high I had the airflow. So if you look at our least dense coffee, the Brazil, only at the 70, the lowest airflow setting that I used in the experiment, did we retain all of the coffee in the drum. But at 75% airflow, it was only 1/10 of a gram. That was really one bean that was pulled out. So that's not a big deal. At 80% of airflow, you're losing about 1/2 gram. And then at 85, you're losing more substantial amount of coffee. At 90% airflow, all of the coffee was sucked out before the end of the roast. And in Myanmar, if you look at that final column, for 70, 75, and 80% of airflow, all the coffee stayed in the roasting chamber, which is great. But once you get up to 85% of airflow, it started to suck some beans out. And at 90%, all of the coffee is out of the chamber. Went through a similar process then with the Ethiopia, and you can see Ethiopia stayed in the chamber all the way up through 80%, and then at 85%, you started losing some. Nicaragua was the most dense coffee that was used here, and it retained coffee, all the coffee from 70 through 80, and even at 85, it only lost like a half a gram, so not very much, and it didn't lose that much even at 90. So these coffees acted differently because of their density. I think that's pretty clear, and they acted in a predictable manner. The higher the airflow, the more likely it was to suck coffee out, and the higher the density, that of course mitigated against that. Here's another way of looking at that for each of these coffees. The colored bars are how much coffee was retained inside the chamber. So you can see for each of the Brazil, the Myanmar, and the Ethiopia, by the time you get to 90% of airflow, it's sucking all the beans out of the chamber. But in the Nicaragua, it's still very dense. So it's still most of the beans are remaining in the chamber. Now, what's happening practically there is not necessarily an indicator of taste. So I also tasted through all of these in a similar manner to the other roasts. And my assumption was that regardless of coffee being pulled out into the chaff, that more airflow would create a better flavor in the coffee. And that didn't entirely bear out, but you can see here the results from the blind tasting. And surprisingly, so let's see, for the Brazil, it tended to like the lower air temperatures in terms of flavor, or the lower air speeds in terms of flavor. Even the 70 and 75%, I said in a pinch. These weren't the best kind of clear decision-making flavors, but they would work. At 80%, you get a really nice, useful sample roast. And at 85%, the flavor was also great. At 90%, you actually, so this is another interesting thing that I found in my quote-unquote research here, is that with lower airspeed, you tend to get more dry distillation flavors. I don't know what I assumed, but I might have assumed that it was the other way around. And with the highest air speeds, you actually get more raw vegetal flavors. So at 90%, the Brazil tastes really sour, nutty, wheat-like, and dusty. With the Myanmar, at the lowest setting, you start to get some roasty characteristics. That was true also for the Ethiopia and for the Nicaragua. And again, these were randomized and tasted blind, so I didn't know what percentage they were. And in all three of those coffees, you picked up roasty flavors at 70%. 75% would work in a pinch for the Myanmar, but you got dry distillation for the Ethiopia and the Nicaragua. And then when we get to 80% and 85%, you see right across the board, this works. Nice clear flavor, good for evaluation of coffee. When we get to 90%, you can see the results vary depending on the coffee. So those were 3 experiments that I put to see if it was even possible to come to a universal sample roast that would apply to widely different coffees. One other thing to mention is cooling with the Ikawa. I don't know how other people do it. So it's air cooled in the chamber to about 100 degrees from 420 degrees. And I always take it out and give it an additional cooling by kind of laying it out as flat as possible. So you can see this is my work from home setup as I'm roasting through different batches, laying them out to cool. And cooling from 420 to 100, it does that rather quickly. And then I just kind of lay it out and let it air cool for the remaining time. So you want to have space when you're doing this, to do that and to stay organized, keep everything labeled and not mix up samples.
Drew, we have a question.
Yeah.
The question is from James, and he asks, are the percentages that, are these percentages running for the whole roast, and do they change at first crack?
No, thank you for that clarification. So in that experiment, those air percentages, it just changed to those percentages at first crack or at 6.5 minutes, essentially, whether it was hitting first crack at that time or not. Because it's the end of the roast where the coffee becomes less dense, and that's when it's the most liable to be sucked out of the roaster. That's when you're going to have to manipulate that factor. So I just put this slide in here. Moisture varies from coffee to coffee, and it also is something that can be a significant factor. As you're working with the Ikawa, you want to pay attention to this. I found density to be much more important, and that's why I focused on that here. But if you remember the first tasting, which was time, it was the two coffees that were the driest that didn't do well at the 8-minute roast. So moisture is a factor. It's something you may take into consideration when you're developing your own profiles. And I just wanted to mention that before reaching these final conclusions. So with sample roasting on any machine, one of the biggest challenges is that you're likely dealing with a lot of different coffees that have different variables, as we've mentioned. You're trying to create a consistent output where roast is not a factor, but you have one kind of low density natural Brazil and one high altitude washed Kenya and a geisha and blah, blah, blah. How do you create consistency with those kind of inputs changing all the time? Density, we've seen, is a significant factor in this. And what we were looking for is the fewest profiles acceptable. And we wondered if it was possible to create one universal profile for sample roasting, kind of like ready-to-wear clothing. You pull it off the rack, you're a size X, Y, or Z, and it tolerably well does the job and fits you. That's what I was trying to find when it came to sample roasting profiles here. My conclusion is that yes, it's actually more possible than I thought to create one single universal sample roasting profile that applies to very different coffees. You don't have to have 3 or 4. You don't have to have one unique profile for every different coffee that you roast. There is one profile that will do the job across the vast many different kinds of coffees. And I accomplished this by methodically tasting through these different elements and seeking the common denominators, as you saw. What rows did we find that all coffees worked? In some cases, there were other rows, like the Ethiopian tasted the best at a little bit lighter temperature, but at 420, all of the coffees tasted good. So that's what I mean by sort of the common denominator, finding the common denominators with all those variables. When you're working with this, be ready to adjust the airflow if a lot of beans are sucking out. At first, I was really trying to avoid this happening at all. But what I've come to is that sometimes the best flavor is going to happen when, with, for instance, that Brazil, you might be sucking out a 0.5 gram or a gram of coffee with the airflow. That's not a big deal. But what I would recommend is don't mix those beans back in and cup them because they're not going to be fully roasted. So dump those out and just retain whatever beans stayed in the chamber for the entire roast cycle. Be ready to adjust the end temperature if the flavor is not acceptable. Most likely, you would only have to adjust what we've come to here if you're working with coffees that are really outliers in density or moisture type. So this profile is going to work for a vast majority of coffees. If you're dealing with monsoon Malabars or something that's 14% humidity or Robusta or something very different, then you may have to make some adjustments. But still, what we've come to is a good starting point for you to make adjustments from. And if you're going to make changes, associate those changes with metrics that you can measure prior to roasting, things like density and moisture. So you can measure the green and say, oh, I think I need to make a little bit of a change here to my airflow or to my end temperature. So what we've gone to is finding a roast that can help us to be efficient as a sample roaster. I don't need to have a separate profile for each coffee. I can just bring up my sample roasting profile, load it, and go to town, roasting different types of coffee. And I'll still be able to achieve a consistent result time and time again. In fact, this machine is amazing in its ability to produce consistent results time and time again. It's not going to get distracted like you and I are. And we've come up with a profile that we can trust for true sample evaluation and purchasing. So where did we end up with all of this? A 7-minute roast was best, 420-degree end temperature, and 80% airflow did the best job for creating a flavor that works for sample roasting and evaluation. So that is it in a nutshell. At this point, I want to again reintroduce Jeff from Ikawa, who's here with us, and allow him to say some final words about the Ikawa. And he and I both can be available for questions if you have any questions.
Thanks, Drew. That was really fun. That was comprehensive, and I really enjoyed that. That was really nice to go through that journey with you. Yeah, I think from my side, I think you've covered everything that I might want to touch on. But like you said, I'm happy to open this up to folks if they have questions, maybe on the more technical side about how it works or anything like that. More questions about our company. From a use case scenario, you're definitely the expert here, and as you've demonstrated. So I don't really have anything that I could add to that other than, it was a really great presentation. I myself have a roasting background, and I was a green buyer for a while for a roastery, and I was actually a customer before I was working at Ikawa. For many of the reasons that you've said here, it's just a really convenient machine. And so, I'm on a personal level also just really interested on that sort of geeky roasting side too. It's nice to see some insights on that. And yeah, it was really, really great. And happy to answer any of those sort of more technical questions or maybe company-based questions that folks might have as well.
Cool. Thank you, Jeff. And thanks for taking the time out to be here. So does anyone have any questions for Jeff?
Yeah, I do, if I can jump in. I guess for me, just interested about I guess just like the fundamentals of the machine, setting the profile. I guess if I understand correctly, is it just a kind of constant feedback loop between the what would you call it? The element temperature and the bean temperature, just kind of going back and forth adjusting in order to keep the bean temperature on profile? Is that how it essentially functions?
Yeah, exactly. So it's not exactly a bean temperature probe. There's not enough coffee in there to have a constant connection with the beans. So it's measuring the air temperature just above the beans, and that's what the red line represents there on the graph. And there's a PID controller within the machine that responds to that sensor, and it aims to maintain that profile, and it does so by adjusting the inlet temperature, so how much heat's coming into that roasting chamber.
Does the fan speed or the airflow temperature contribute to that as well? Like, are you, and not that I suppose you'd have to worry about it because it's like sort of self-regulating, but I mean, I was interested when Drew was going over his profiles, kind of wondering whether or not the additional airflow would lead to sort of different application of heat to the beans, and how that kind of pans out during profiles or during roasting.
Yeah, really good question, and it does. So because it is a the airflow does quite a few things in that roaster, and so changing the airflow does change the heat application as well. And so when the airspeed changes, then you can kind of think about it like a river. You're changing how much energy is being applied to that bead mass. And so what you're observing, Drew, with the lower air temperatures resulting in some of that dry distillate flavor is a result of needing to achieve a certain air temperature in that roasting chamber. Because there's less airflow coming into chamber, the way that the roaster will adjust is by increasing the element temperature. And so you'll notice that the inlet temperature will actually go up when if you did the exact same profile and the only difference was air or speed, the inlet temperature will change a little bit to compensate to still achieve that profile line. And so, yeah, to your point, it will affect it. Yeah.
Cool. Any other questions? Either to Jeff or, oh yeah, go ahead.
Oh, thank you both of you guys. It's super interesting. It makes me want to go over and borrow that Ikawa, Drew, from your house. But I just had a couple questions. I feel like a application that would be really useful, and I know maybe I've done some of this, but is if you're comparing with like a producer organization, exporter. And so I was wondering how, like if you're sharing a profile with someone that has a 100-gram version versus the 50, if that changes anything, or if the elevation is really different or ambient temperature, how that impacts the profile sharing.
Yeah, good question. We don't. So at the moment, we just have a 50-gram model.
Oh, okay.
So that's
okay. Never mind then.
Just the one capacity size. But to your other point, the altitude definitely affects things. So the roasters, when they leave our workshop, they're all calibrated, and we do that based on a set few profiles and coffees and then color outputs. And so when they leave, they're all very tightly calibrated. But like you mentioned, like altitude is going to be a big factor in how that water leaves the coffee, like at what point it does, and therefore how it roasts. And we found, again, it's a complicated thing because the airflow does quite a few things. And so because the air is less dense at a higher altitude, it carries less energy. And so to compensate for that, we found that increasing the airflow at altitude actually helps produce that better roast. And to your question about the communication, I think it's a really neat application, and I'm personally trying to learn more about how successful people are with that. And I don't know if you at Atlas have done any profile sharing across either to colleagues or partners, but it's something that we've seen roasteries use quite well on like a direct relationship. And there's always going to be some adjustments, I think, that are needed just based on those environmental conditions, like you mentioned. But a profile usually gets people to a really close starting point, if that makes sense. It gets them within a good ballpark, and I think it helps open the communication up to say, okay, we're roasting this very similarly at least, and then we can have a more in-depth conversation, I guess, on the cupping table. So.
Great, thank you.
Yeah, welcome. Drew, do you know, have you, what's your experience with sharing profiles? Have you found the consistency been pretty good, or, across different countries, does it vary a little bit, or?
Yeah, I would say I don't have a large data set. I've been sharing more than anyone else. I share with Tamika, who's on the East Coast and works for Atlas, and that has worked just fine without problems. I haven't done extensive sharing with producer partners that we work with. Mm-hmm. So yeah.
I've got another one for Drew if we have the time.
Sure.
I guess in And also, thanks. I forgot to say that in my first batch of questions. Thanks so much, both of you, for putting this on and taking the time out, and Drew for doing all the hard yards in that research. It's just super interesting to look at those side by sides. But my questions are just thought process was, because with sample roasting, traditionally so much of it is based off of that actual kind of like audible first crack, and then monitoring your development time, maybe by time or color. So I guess just getting your take on that kind of conversion, going from development time and first crack to actually just running things purely by temperature. That, and then I guess leading into that, or leading on from that, have you tried applying some of these profiles or roast curves back to a barrel roaster, and how has that worked out, if you have?
Well, let's see. I think that one of the things that, as a person who's spent much of my career, more than 10 years sample roasting, probably 15 or something, much of that on a traditional sample roaster. It is an adjustment in the way that you think about sample roasting when you move to an Ikawa. Like, what I'm used to working on, like a Probot or something similar, is like sort of a constant like interaction between me and the machine and the coffee, observing the coffee, making a split-second decision. And at any point, if I'm roasting for 8 minutes, at any point within that 8 minutes, I can decide based on my observation, oh, this needs to change. It's moving too fast, it's moving too slow, it hit first crack here, it hit first crack later or earlier than I expected, and I can adjust on the fly. That's not something that's possible with the Ikawa. Like, you program it ahead of time, and then it carries, it out. So, that is one thing that one could explore more than I have here. Looking at the different coffees here, when did they all actually hit first crack relative to when I expected, which was, within 18% of the end of the roast. They all did hit first crack at somewhat different times. So they, in honesty, had different development times. I wasn't trying to make that a stable thing, as stable as possible. But I think my ultimate goal was to create a universal profile that would work flavor-wise. So at the end of the day, I was judging based on flavor outcomes, and you saw the results based on that. But it would be another interesting data point to look at, the development time or when first crack happened to each one of these. In terms of, but I would suggest like not having that as a variable in this test. The ones that worked universally, so it didn't seem to be a limiting factor for a good sample list. In terms of applying this back to a traditional sample roaster, honestly, I don't think, our sample roasters have no thermocouples, so there's not really much of a way that we could do that, because we can't apply, the metrics that the way that an Ikawa allows you to see what's happening is kind of amazing, because you have it in real time showing you the profile. We just don't have anything comparable with our traditional sample roasters. All right, any other questions?
I do have a question. Is Ikawa planning, if it can be shared, Jeff, on coming out with a 100-gram version or a different version at all in the near future, or sticking with 50?
I think we're always listening to user feedback, and we're working on things. Is that a request then from Atlas? I think we're always looking to know what our users want, I guess. So
I think 100 grams would be helpful to see. Definitely. That's something that with the previous roaster I worked at as well, we were looking at Ikawas, and that's seemed like was a kind of limiting factor for us. But I mean, I don't know. I guess like to what Drew was saying, it's kind of a different approach from a conventional roaster, and maybe it doesn't need to be, looked at the exact same way. But certainly it'd be helpful to have more roasted sample.
It's not an uncommon request for sure. I think we've heard that more so and more recently, I think, for some reason. But it does seem like we've heard that a little bit more often than not norm. So yeah, it's an interesting one to look at. I think that more people are wanting to do the sort of 5 bowls on their cupping table for each coffee, and 2 roasts is less, it's possible, of course, but yeah, it's an interesting one to bring up.
Well, thank you guys for showing up today. Thanks for all your questions and the discussion. I hope this was useful and informative for you. And thanks to you, Jeff, for showing up today and adding the Ikawa perspective and depth of knowledge on these machines. So thanks, everyone. Thanks for being here for the class, and I wish you a happy Friday.
Thank you so much. Really appreciate it.
Oh, real quick, everyone, there is if you pop over to the chat thread, I just posted the link to the survey, which Drew hopes that you can take some time to fill out. So, yeah.
Thank you. Will do.
Will do. Thank you.
Okay.
All right. Thanks,
Bye.
everyone. Bye.
Bye.